Today we're going to review the 6.2C lesson, Solving Scale Drawing Problems and Creating a Scale Drawing. So as a reminder, the scale indicates the proportion between the representation, the model, and what it represents, the actual. Now that's in contrast to our scale factor, which is our multiple. We're going to play with both of those today. So number one, your sister wants a large poster version of a small drawing she made. She drew it on centimeter graph paper. What are the dimensions of her original picture as shown to the right? So I'm going to count up the number of boxes so that I can find my dimensions. And I find out that this right here is 8 centimeters. So then from here down to here, I count those up, and that's 6 centimeters. So I'm looking at 8 centimeters by 6 centimeters. That's her original drawing. She wants the poster version to have a height of 2 feet. What scale should she use so that her poster is 2 feet tall? So right now it's 6 centimeters tall. So 6 centimeters for our original, and I want it to become 2 feet. So I have a scale there, and I could simplify that scale as well. So for C, the side of the square on the grid in the original picture is 1 centimeter long. How long will the side of a square on the grid be in the final poster? So I'm still comparing my original to the poster, or my centimeter compared to the feet. And I know that every 6 centimeters is 2 feet. And I want to know what happens if I just have 1 centimeter. So I can set this up with a proportion and use an X, or I can just do a little bit of scaling, and that's what I'm going to do here. So I'm going to multiply the top and the bottom by 1/6, and I get 1/3. So for every 1 centimeter square, I'm going to see that 1/3, or 4 inches. So the side of the square on the grid of the poster will be 4 inches, or 1/3 of the feet. So go ahead and write that out in a sentence, please. So again, the side of the square on the grid of the poster will be 1/3 of a foot, or will be 4 inches. So what will the overall dimensions of the final poster be? Well, I know for every little box, it's going to be another 4 inches. So to find the height, I'm going to say 4 inches times the 6 boxes would equal 24. And then 4 inches times the 8 boxes at the bottom would equal 32. So I can say the final poster will be 32 inches by 24 inches. Now I could have also done this in feet. Instead of multiplying by 4 inches, I could have multiplied by 1/3, and I would have gotten 2 2/3 feet by 2 feet. So I have some options because it didn't tell me what my units had to be. All right, number 2. Hal used the scale 1 inch equals 6 feet for his scale model of a new school building. The actual dimensions of the building were 30 feet, and that's the height, by 120 feet the width, by 180 feet the length. So we're going to practice our scaling here again. So I have the inches from the model to the feet, and I know every 1 inch is 6 feet out there in the world. And for the first one, I have 30 feet. So 30 is going to go on the bottom, and I'm going to scale, and I'm scaling up by 5. So I get 5 inches. We're going to do the same thing for the width and the length. So please hit pause and then find the width and length. When you're ready to check your answers, hit play. All right, so to find the feet, we had to scale up by 20 to find the width, and then to find the length, we had to scale up by 30. So the dimensions of the scale model are 5 inches by 20 inches by 30 inches. So it asks us, what is the scale factor here? Well, I know that the scale itself, the scale is 1 inch to 6 feet. Now to find the scale factor, I need these to have the same units. So I'm going to convert them to inches. So 1 inch would be 72 inches. And I found that by taking 12 times the 6 feet to convert it to inches. So that means to get from the model to the building, so this is getting bigger, our scale factor is going to be 72. I have to multiply by 72. To go the other way, from the building to the model, my scale factor is going to be a reducing scale factor. It's getting smaller, and that's going to be 1 over 72. All right, so using what we know now about number 2, I want you to try number 3 on the next page, A, B, and C. And I want you to think about your common units. What do we know about those units? All right, hit pause, give it a try. Let's check in on just part A. So finding the dimensions, I'm thinking the inches over the feet, and then I'm going to scale. So the scale drawing of the classroom is 2 inches by 1 3/4 inches. So now finding the scale factor of classroom length to drawing length. I'm going to start out with what I know about the scale. My scale is 4 feet to 1/4 of an inch. Well, again, I need to have common units as I look at scale factor. So I'm going to take that 4 feet and change it to 48 inches to 1/4 of an inch. Now, scale factor is a lot easier if I have a unit right here. So I'm going to find out that if 1/4 of an inch, if what that is, if I have 1 inch. So I'm actually going to scale here by 4. So when I do that, I get 192 inches to every 1 inch in the drawing length. So then I can see that my scale factor to get to the drawing, remember that's going to be a reducing scale factor because it's getting smaller, will be 1 over 192. Now for C, it says what's the scale factor of the classroom area to the drawing area? So on this one, I want to remember to find my common units right from the beginning. So I'm going to change that 32 feet and 28 feet into inches. Once I know the inches, I can then find the area of each of those to find the scale factor. All right, give this one a try. All right, so starting here, we multiplied both by 12 to convert it to inches, and then we did length times width to give us the area. Over here, we did length times width again to give us the area. Then we're going to convert to find the unit rate because it's easier to work with unit rate. And so now we have our scale that we can use to convert to scale factor. So scale factor again is a reducing scale factor. So we're looking at multiplying by something less than 1. So our scale factor is 1 over 36,864. All right, looking at part D, what is the mathematical relationship between scale factor for length and scale factor for area? And we're seeing that these are actually squares of each other. The scale factor for area, the scale factor for area is the square of the scale factor for lengths. And that should sound really, really familiar from when we were first going through 6.1 and we were talking about the relationship between the change in dimensions and the change in area. All right, I want you to read through number 4 on your own. reading the questions carefully and identifying what's true and false. And if it's false, give me a quick explanation of why it's false or what we would have to do to make that true. So again, thinking carefully about what the problem is telling you in number 4. Let's hit pause and give it a try. All right, so as we look through number 4, it says Audrey wants to make a scale drawing of the stamp below. She uses a scale drawing where 1 centimeter in the drawing represents 3 centimeters on the stamp. So I started right here by just sort of picking out what I know. So I know for every one thing on the drawing, there's 3 things in the actual stamp. And then as I go through my different trues and falses, I'm able to keep referencing back. So A was true, B was true, C and D were both false because we know that the area will be squared of the change in the dimensions. So that would be 3 squared is 9. And then for E, that one is also true. All right, let's flip the page. I want you to read through number 5 and decide which one of those has shrunk the most from the original, and then kind of explain your answer as you go. And I want you to be thinking about when you're looking at these, it's the drawing, compared to the actual. All right, let's give that a try. Hit pause. All right, so as we look at our 4 different measurements here, we see that the 2-mile scale is going to have shrunk the most from the original because it has the largest difference between the length of the model and the length of the actual. All right, let's look at number 6. And as we look at number 6, it says the scale drawing on the right is 1 unit to 1/4 of a foot. And then on the one to the left, we want to do 1 unit to 1/2 of a foot. Now, it's sometimes a little bit hard to tell when we have that fraction in there of, is it going to be an enlarging or reducing scale factor? So let's think about this for a second. If I have 1 unit is 1/4 of a foot, that means it takes 4 units to get to a foot. Whereas in my new one, 1 unit to 1/2 of a foot, it's only going to take 2 units to get to a foot. So I am actually going to be reducing our figure here. So for every box I see here, it's going to represent half a box on this other side. So if I count up on this little doggy, 1, 2, 3, 4, 5, 6, then over on this side, I'm actually just going to go up 3. All right, I want you to hit pause and go through and draw the rest of our little guy here. All right, once you have your little guy drawn, it should look something like this. It should be identical to our previous one, just a scaled version or a reduced scale version. All right, that leads us to the end of our 6.2C lesson. So you are now equipped to try tackling that 6.2C homework. Good luck.